So this is going to be a review for the topics covered on the Unit 4 test, graphing, absolute value, quadratic, square root, vertex form of a quadratic, and transformation. So let's look at our first example. So first we're going to graph an absolute value. So notice first that this is in vertex form. So if we can see the transformations, we know that the original parent graph looks like this and has a vertex at 0, 0. So if we know that this has been flipped, which doesn't move the vertex, right 2 and down 3, then we know that our new vertex is at positive 2, negative 3. So positive 2, negative 3. Then I can find a point on either side. Now you can use symmetry, or you can just plug and chug any number less than 2, any number greater than 2 into the equation. Now I would like to choose 0. It's just making the math easier. So I'm going to plug that into the equation. I get the opposite. 0 minus 2 is negative 2. So I have negative. The absolute value of negative 2 is 2 minus 3. And negative 2 minus 3 is negative 5. So I have 0, negative 5. Now this is turned down. It's lower than my vertex. So that makes me feel like I'm on the right track, as that negative indicates to me that this is a downward facing or a downward opening V. Now something to the right. If I want to use symmetry, notice that 0 is 2 to the left. So I would pick a point 2 to the right, which is 4. So if I plug in 4, just to make sure that I'm doing this correctly, 4 minus 2 minus 3. 4 minus 2 is 2. The absolute value of 2 is 2. And negative 2 minus 3 is negative 5. That's what I expected to get out. So I have 4, negative 5. Remember that your absolute value is a V. Do not do a parabola. That will get you points counted off. Your whole graph. You will not get points for your entire graph if you graph a parabola. So then the last thing we have to do for this problem is the domain and the range. So domain, so I come in from the left. The first thing I touch is an arrow. Pointing to the left is negative infinity, all the way across to an arrow to the right. You may also use the R for all real numbers. Now range is from bottom to top. So I start at the bottom and I have an arrow pointing to the bottom, which is negative infinity. The highest this graph goes is y equals negative 3, and we're going to use a bracket because that is included. Number 2, this is a quadratic, so we know it should be that parabola shape. Again, it's in vertex form, which makes it very easy to identify the vertex opposite of the inside, so negative 3, 4, because remember this is left 3, up 4. Again, notice this has the negative out front, so I know that my U should be downward. It should open down. Okay? So something to the left of negative 3 or to the right, it doesn't matter which side you start with. So I have negative 3, positive 4. Now I would probably choose negative 1 to the right first, just because the math is easier. So I have negative 1 plus 3 squared plus 4. So I have the opposite. 3 minus 1 is 2. 2 squared is 4, and negative 4 plus 4 is 0. So negative 1, 0. Okay? Now if I choose a point for symmetry, notice that 1 is 1, 2 to the right. So I'm going to choose 1, 2 to the left, which is negative 5. I would expect to get a 0 out as well. Now we can check that algebraically. So I have negative parenthesis 5, negative 5 plus 3 squared plus 4. So I have the opposite. Negative 5 plus 3 is negative 2 squared plus 4. Negative 2 squared is a positive 4. And a negative, the opposite of a positive is a negative. Negative 4 plus 4 is 0. So this, again, should be that nice U shape, opening down. So domain left to right, I come in from the left. I have this arrow that's going to continue moving to the left. So that's negative infinity. I have an arrow that's going to continually move to the right, which is positive infinity. The range, I start from the bottom. I hit 2 arrows, so that's negative infinity. The highest point on this graph is y is equal to positive 4 with a bracket. Okay? The last is a square root. Now we have to be a little more particular about the points that we choose for a square root. we're still going to find that vertex first. Remember, the vertex for the square root is the starting point, so there is no left and right. It starts at the vertex and either goes to the left or to the right. Okay, so my vertex is opposite of the inside, -1, -2. So I have -1, -2. So then from here, I want to make sure that I choose points that's going to result in my radicand being a positive or a perfect square. You can't graph an irrational number, so let's try and pick something that's a perfect square. So I would choose 0 first. The square root of 0 plus 1 minus 2. 0 plus 1 is 1. The square root of 1 is 1, and 1 minus 2 is -1. So I have 0, -1. I could also choose 3. So I have 3 plus 1 minus 2. 3 plus 1 is the square root of 4 minus 2. 2 minus 2 is 0. So I have 3, 0. I could choose one more. Any of these points, you have to include the vertex, but any point after that just helps you graph. So I have the square root of 8 plus 1 minus 2, square root of 9 minus 2, and 3 minus 2 is 1. So I have 8, 1, and you get this nice little curve. Now the domain, I don't come to an arrow, I come to an x value of -2, and I end with an arrow going in the right, which is positive. For the range, I'm coming up from the bottom. The first value that I touch is not an arrow, it's a value of y equals -2 to positive infinity. Now I graphed this wrong. I'm so sorry. This should be here, -1, -2. Here, -1, -2, which makes my domain a little bit different. So we come in here, it's -1 to positive infinity. Okay? So to put this in vertex form, remember that we have to complete the square. So remember, we always group these two together. So I have x squared plus 6x. I'm going to draw my blank, -5, and my blank to keep my equation balanced. So remember, to fill in the blank, we take half of the center term and square it. So half of 6 is 3, and 3 squared is 9. Now remember, we can't just go into an equation and just add 9 and it be the same. So we want to zero that back out, and 9 minus 9 would be 0. Notice if I tried to simplify this right now, it would return me back to this equation. 9 minus 9 is 0, so I would be left with x squared plus 6x minus 5. That's how I know I didn't change this equation. From here, remember, the whole purpose is to be able to write this as a perfect square. Plus 3. Now remember that when we square this out, what we're really saying is x plus 3 times x plus 3. So we're always going to get twice this term, 3 plus 3 to get 6 and 3 times 3 to get 9. We have x times x is x squared, and then you get that double 3x, so plus 3x plus 3x, and then 3 times 3 is that plus 9. And then, of course, a -5 minus 9 is -14, so my vertex form, x plus 3 squared minus 14, with a vertex at -3, -14. For this one, remember, we still group these two terms, but this is supposed to have a coefficient of a +1, and whatever I do to the x squared term, because they're grouped, I have to do to the x term. So if I divide that 2 out, remember, you don't divide it away from the equation, you just bring it out like a GCF. You have x squared plus 4x, 8 divided by 2 is 4. So if I redistribute, I get the same thing, a blank, a -10, and a blank to keep my equation balanced. So remember, what goes here is half of the center term squared, half of 4 is 2, and 2 squared is 4. So now remember, distributive property says that I distribute to everything, so 2 times 4 is 8. So to get rid of a +8, it's a -8. Now remember, you should be able to simplify this problem as if you were working it and get back here. So if I distribute the 2, that's 2x squared plus 8x plus 8 minus 10 minus 8. and these two go away and leave me with exactly what I started with. So we know we did not change the equation, so I have y equals 2 times my perfect square, x plus 2 squared. A negative 10 and a negative 8 is negative 18. So I have 2 times x plus 2 squared minus 18 with a vertex at negative 2, negative 18. Okay? So this problem asks for the parent function. So I know that this is a quadratic because it is squared. My transformations, remember this out front tells me whether it's a stretch or compress. It tells me if it is less than 1, it is a compression. Greater than 1, it is a stretch. So this is a compression by 1/3. Right 3 on the inside, opposite of the inside, and down 5. Now I do want to make a note that just because you see a fraction does not make it a compression. There are fractions that are greater than 1. This is 2 point something. Okay, so definitely not a compression. It is definitely a stretch. So don't just assume because you see a fraction that it's a compression. Make sure that that fraction is less than 1 before you make that determination. Okay. Number 7, this is an absolute value. Okay, the negative out front tells me it's flipped. 5 is greater than 1, so this is a stretch by 5. Inside is opposite, so that would be right 6, and the 3 would be up 3. So I know that this is the square root function, and the original looks something like that. Okay, so I know immediately, so this is square root, I know immediately that this has been flipped over the x-axis. So flipped has been moved left 2 and down 3. So this wants us to construct the equation. So I'm going to know that this is the quadratic function, so I know it's something squared. So 3 down, 7 to the left, and flipped. So I know the flipped has to go out front. The left and right is inside and it's opposite. So if it moved left, it's positive 7 squared, and 3 down is minus 3 on the outside. Okay. Number 10, the square root function. So I know it's going to be this. Stretch by a factor of 7 and up 5 units. So nothing happening with the x under the radical. So I'm going to have 7 times the square root of x and then up 5 units. So this is the absolute value compressed by a factor of 2/5, down 5 and right 6. So I'm going to have 2/5 on the outside. Left and right goes on the inside, so if it goes right 6, that would be inside is opposite, and then 5 units down is minus 5. Number 12, so I know that this original looks roughly like that. It's a parabola that sits at the vertex, y equals x squared, so I know that I go left and right on the inside, so it went left 1, so that's positive 1 squared, and then up 2. Number 13, again, I know that this parent graph looks something like that. So I know it's been flipped, so that negative has to go out front. Square root, left and right goes inside. So it went left 5, so remember left 5, inside is opposite. Plus 5, and then down 4 is a minus 4 on the outside. 14, again, I know that this is the square absolute value graph. The original is at the origin. So I know that it went left 2, so inside is opposite, x plus 2, and then outside is my up and down 3 is minus 3.